Alright, this is section 1.4, continuity, and this section will be discussing what a continuous function is and how to go about evaluating or checking for continuity. Now, the easiest explanation I can give you guys as to what a continuous function is one I was given when I was a student, and that's as if you can draw your function or your graph without lifting up your pencil or your pen or your marker. That's going to be a continuous function. Now, as soon as I stop and have to maybe, let's say, move from one side to the other because of a jump, then it's no longer going to be continuous there. Same thing, let's say if I have to overcome a vertical asymptote and I have to go shoot way down over here. In order to cross this and continue my graph, I have to lift up my marker, or lift up my pencil or my pen, and it's no longer going to be continuous there. So if you can draw or sketch this in a smooth, continuous way, the function is continuous. As soon as you have to lift up your marker or your pen, it's no longer going to be continuous at this point, and also, let's say, at the vertical asymptote. So the mathematical definition of what a continuous function is as follows, and I'll explain this in just a second. There's three things that have to be met. A function is said to be continuous if these three things, all three of them, are satisfied, or all three things are met. First thing is that it has to be defined at that point, meaning that I have to be able to find a value for it at f of c. Second thing is that the limit has to exist. I have to be able to approach c from both sides, and the function has to give me the same sided limits. And then the third condition is that the limit has to equal the definition. So condition 3 kind of summarizes these two, saying that if these two are valid, then they also have to equal each other. So let's look at an example. Here's a graph of a function. So we're going to determine if the function is continuous at the specific values, and then state the type of discontinuity. So when something is not continuous, we're going to say it's discontinuous, or say the type of discontinuity. Alright, so at x equal to 1, I can see that my graph is in fact smooth and continuous. There's no lifting, there's no hole, there's no jump, it's just a continuous graph. So you can just say that it is in fact continuous. At x equal to 2, first of all, it is defined, so the first criteria is met. Number 2, the limit does exist because I could approach 2 this way, and both sides meet up at the same point, which is going to give me a limit of 1, 2, 3, and 4, so a limit of 4. However, the limit does not equal the definition, meaning that the hole is filled in down below, so this is not continuous. And after I go through these examples, I'll talk about the types of discontinuities. For part C, it's asking at x equal to 3. The limit from the left appears to be 1. The limit from the right appears to be 5. So obviously there's going to be a jump. So this is going to be a not continuous. So anytime you have a jump, it's an automatic not continuous. D, the limit, or the x equal to 5. I can see there's a vertical asymptote coming in from the left, taking me to negative infinity, coming in from the right, going towards positive infinity. So this is going to be a not continuous. Now, as far as the type of discontinuities, well, I could maybe fix this continuity by moving this point, this circle, in where the limit is. So this is going to be something called a removable discontinuity. Removable because all that's wrong with it is that number 1 and number 2 don't agree, but everything else, these two are satisfied. So if I were to just maybe find a way to fix this definition and put it back inside the limit, then it would in fact satisfy all three. So this is a removable discontinuity. It's more of the fixable types. This one over here is going to be discontinuous because of the jump, and unfortunately we cannot fix jumps. There's no way to really do much with a jump. So this is going to be a non-removable discontinuity. And the same thing applies for D. As far as a vertical asymptote is concerned, that's also going to be a non-removable. So to kind of summarize this, we have two types of discontinuities. One is if it's removable. That's if I have a limit, but the limit doesn't agree with the definition. And then I have non-removable, which is if I have a jump or if I have a vertical asymptote.